Good afternoon, Engineer Fredelino Galleto Jr. In this video, we are about to share how we came up with our Yagi-Uda antenna with dipole elements and modified reflectors.
And in this video will be divided into sub-parts. So the first part will be the introduction, then the calculations, then the third part will be the preparation of materials, the next is the assembly and finishing touches, and then the recording of our antenna with its connections from antenna to TV, and then we have the recorded TV channels, and lastly are the proofs of how we made this antenna. So I hope that you enjoy this video
And you will learn something from this.
Thank you.
Thank you so much.
So good day everyone. Now we will share to you the calculations for our Yagi-Uda antenna with dipole elements and modified reflectors. So first, this Yagi-Uda antenna is a phased array antenna, which means all elements are fed or are driven except for the reflectors. And then the elements consists of several dipoles. So we decided that the bandwidth of the design is to be 250 megahertz to 650 megahertz. So when calculating the center frequency, we have 250 megahertz plus 650 megahertz all over 2, and the center frequency is found to be 450 megahertz. So for the wavelength, we have the formula speed of light over center of frequency. And speed of light is 3 times 10 to the power of 8 meters per second over 450 megahertz, the frequency. And so the wavelength is found to be 0.67 meters. So now we can solve for the length of the reflector or H reflector. So that is found by 0.55 lambda. And then we substitute the value of lambda. And so we have 0.55 times 0.67 meters. And so the length of the reflector is found to be 0.37 meters. And then here, the length of the driven element. So it is found to be 0.5 lambda. And so substituting, we have 0.5 times, we have the lambda is 0.67 meters. And so the length of the driven element will be 0.34 meters each.
For this antenna design, we decided that we will have 5 directors. For the first director, its length is 0.94 times the length of the driven element. So, the length of D1 is 0.94 times 0.34 meters, which is 0.32 meters. For the second director, it is 0.84 times the length of the driven element. So it is 0.84 times 0.34 meters, which is 0.28 meters. For the third director, it is 0.74 times the length of the driven element, which is 0.25 meters or about 1/4 of a meter. For the fourth director, it is 0.64 times the length of the driven element, which is 0.21 meters. And lastly, for the fifth director, it is 0.54 times the length of the driven element, which is equivalent to 0.18 meters. For our spacing, it is the wavelength multiplied by 0.2, which is 0.2 times 0.67, which is 0.134 meters. And the boom length is 0.134 times 7, just simply the spacing plus the 5 directors plus the driven element plus 1, so 7. So 0.134 meters times 7, which is 0.94 meters. And lastly, the diameter of elements used is 0.8 centimeter each. Making the antenna, these are the materials that we use. Pliers, and cutter, electrical tape, screwdriver, balloon with a ratio of 4:1, ruler, is clipper, nuts and bolts, and wires.
We have also used sandpapers, and then scissor, and then some aluminum rods for the antenna, and a drill bit to drill holes, and of course coaxial cable, and lastly the circle boom. Engineer Fredelino Galleto Jr. I am Munleno B. Presto.
And I am Eric Dominic D. Manginsay. Today, we are going to present our antenna as one of our requirements for the subject Transmission Media, Antenna Systems and Design.
So there you go. So for the antenna, we have permanently laid or temporarily laid the antenna here because of the rainy weather for today. So this is our antenna. So we have copied some of the characteristics of this antenna from one of our sources. So we used a reflector here that has a 4 reflectors that help all in all to reflect back the wave. And here we have the driven element. So that is the driven element. This is the driven element. And we have 1, 2, 3, 4, 5. We have 5 directors. So all in all, the driven element and the directors are connected in series. And all in all, they are connected finally onto the balloon. That is that has a ratio of 4:1 balloon.
The balloon is connected to the coaxial cable, and in which the coaxial cable is connected to the antenna port of the television. The television is powered by a 220 volt AC source.
So the television is powered by 220 volt AC source, and as you can see, there is one channel that has been received by the antenna, although it hasn't been positioned very permanently or good because of the rainy weather. And this is the GMA channel that we have got. So some channels were also received, and you will see it in the next videos. Where all the connections were made from the antenna into the antenna input of the TV, we need to program the TV so that it can receive channels that are free or in air. So to do that, we just press the menu and then put down onto the channel, and we select the air. So here we select, we can see we already selected the air, and then after that we can auto program so that it will automatically search for different channels.
COVID-19, una sa paghahatid ng pinakamalalaking headlines ng bansa. Frontline sa umaga.
Ako po si Marga Vargas.
Ako si Paolo Bejones. At Frontline Pilipinas.
Ang ganda. Prina, puro yelo. Ayos lang. Pareho nang nasa picture. Hindi naman ito isang kolehiyo. Meron silang ski school dito. Prina.
Tama na, yun tataga. Okay na. Wala.
Okay na, wala.
Video na ni mo. Sa mga kabira na.
Rice Krispies and rich chocolate. How do you get the straight and silky hair you love? I blow dry it. I rebond it. Not afraid of damage.
Good afternoon,
Lag.
Sige lang. Diretso na.
Good afternoon, Engineer Fredelino Galieto Jr.
Ikaw.
Wala.